so thanks so much, Datafold, for having me. I'm excited to speak with you a little bit today about data quality and how you can think about data quality depending on if you're a small, medium, or a large organization. So I'm going to go through these three different company sizes and hit some best practices, some what to do's and what not to do. Before I do that, I want to tell you a little bit about myself. So I work at Spotify as an analytics engineer. Previously, I worked at a company called Milk Bar, which is a popular bakery in the US. I normally live in Brooklyn, and I've worked on a few different open source projects that I wanted to put out here if you are a Looker user. And then you can see my social there at the bottom. So today, going to be discussing a few different sizes of analytics teams. The key sizes, I think, are data teams of one, where you have one person, small to medium, which is probably somewhere in the realm of 5 to 20 people on an analytics team, and then large data organizations, which get much bigger than that and can be distributed and subdivided. So for each of these stages, I'm going to talk about what challenges are unique and some things you should definitely be doing, some things you should definitely not be doing. So as your company's growing and your data is growing and your analytics team is growing, it gets harder to do a bunch of different things. It's harder to communicate with the people on your team. The data that you're trying to query gets larger and larger, and it takes more time and more resources to extract information about. Yeah, it's harder to track data throughout data pipelines and different systems that might transform it or monitor it. And it's also hard to understand, like Gleb mentioned, as the number of data sets is increasing, sometimes as much as 100x times the number of employees, to know what is the quality of each data set that you might be working with during your job. And then lastly, it also gets harder to communicate with people. You can't just walk over to someone's desk and say, hey, we had an issue, this isn't working the way we think it is. You have to think about doing things in a more formal way. So I love this quote from George Bernard Shaw, which basically says that most of the problems with data quality come down to communication, where we assume something has happened, it's actually not happened, or it's happened differently than we expected, and there was no communication around that piece of information. So I'm going to start with a data team of one, and I'm sure some of you are in this boat. I've been in this boat in the past. So as a data team of one, you're working in a vacuum. You might be new to engineering disciplines like data testing and Git. Also, your work might be unproven. You might be trying to prove to a small company that your effort is justified and that you need a data stack or you need certain tools. So the first thing I recommend is that you really lean on your stakeholders for expertise. You might not, since you are a small team, you may not have a lot of history in the organization. You need to be able to consult with people and ask them, hey, how does this work? How does that work? Also, lean on them as domain experts, but also hold them accountable, because if dirty data is flowing in, you're going to be spending all of your time cleaning other people's data. So hold them accountable, help them understand the implications of what happens when they don't set up that object in Salesforce correctly, or they don't configure things the way that they need to in order for things to work smoothly. Also, leverage the community. So I highly recommend some Slack channels. The DBT Slack channel and the Locally Optimistic Slack channel are both really great places where you can go and just talk to other people who are doing the same thing as you and bounce ideas off of them. Learn how to test your data. It's really important that you can do that you have automated checks that are basically filling in the place of code reviews that would normally exist in a larger team. It's really important that you're testing your data. And leverage open source tooling. I think it's easy for people on teams of one. They want to try the new technologies. They want to try different software and things that they see out in the community, but use the things that are open source. Like DBT is great for SQL. DBT allows you to, from the command line, run SQL against your warehouse, to run tests against it, to manage dependencies between different tables. Great Expectations is another library that's really great for testing assumptions in Python. But don't get distracted by the shiny stuff. Don't get too distracted by going after the next big thing, because those things are usually expensive and they take away a lot of time that you might be able to spend being lean and working on what your company really needs. And lastly, don't get overconfident. So if you're a data team of one, make sure that you're testing the work that you do, because no one else is really checking up on it. So if you're in a small to medium-sized data team, once your company has grown a little bit, you start to encounter different challenges. So at this point, you probably have multiple developers on your team. They might be distributed or they might be embedded in other teams in the org. It's harder to hold a mental model of data. And so at this point, you really need to start thinking about what are the riskiest assumptions that we're making in our data warehouse and how can we test them with SQL. You should set up continuous integration to enforce things like, are my tests passing? Are naming and styling conventions being followed? Like you could even set up continuous integration to look at things like, are people writing doc strings or documentation for the code? And I'll talk a little bit more about continuous integration in a second. But another thing you can do is some basic data monitoring. So you'd be amazed how many issues I've caught in the past just by looking at things like how many rows were added to this table and see that in a dashboard every single day. You can catch a lot of ETL problems just by looking at like very simple things like counts of rows and other metadata about your warehouse. Also, this is the point where you should really start communicating with your users about various incidents that you encounter. So if something's broken, you need to actually send out an incident report about that. You need to be professional. Take that extra effort to show that you're aware of what's happened and you have a fix in place to make sure it doesn't happen again. At this point, I definitely recommend that you buy instead of build. There's a lot of really great software as a service tech out for data organizations to do things like metadata catalogs and managed ETL. And you should definitely purchase these technologies instead of building them. It'll allow you to focus on the business logic and the things that really matter. And finally, have a process for sunsetting or deprecating data. You're probably getting to the point where you have some data lying around that you don't know what to do with. This is a good point to put a process together to inform the people who might be using it, to shut it down and prevent old, unmaintained, and poor quality data from lingering in your warehouse. So if you haven't used continuous integration, it looks something like this on GitHub. You can use different applications that plug into your version control hosting. And whenever you run some kind of pull request or you want to merge new code in, you run these tests automatically to make sure that you have a stamp of approval before you release anything to master. So that lastly brings us to large data organizations. And large data organizations have some really unique challenges as well. Mainly, data starts to get too big to query. You can't query the entire history of a certain table. You maybe need to start looking at things in a partitioned way. Also, sometimes data sets become very numerous. They're duplicative. You don't know what their quality looks like. So there are a lot of ways you can get around this. One way is to use tools that are synthetic data generators. So rather than testing with production data, you can use things like Ratatouille for Scala or Faker for Python, which will spit out data that meets certain constraints and appears like it would have come from your warehouse, but doesn't actually. Also, I would encourage you at this stage to start thinking about how you can test probabilistically. So rather than testing definite assertions, look at things like the mean of this column should be in this range and the standard deviation shouldn't exceed X. Or look at things like the maximum of this column should not be greater than Y, or the minimum should not be greater than 0. Those kinds of things can help you bound the descriptive statistics of certain types of data and make sure that they're in line with what you expect. Also, this is where you really should start investing in metadata. You should think about showing things like data sets that are considered high quality. So for instance, we will often, at Spotify, we'll call things golden data sets that have a stamp of approval on them. So people know that all across the company, this is a high quality data set that you could use. Similarly, we have an automated process called Test Certified for Data, which you can read a blog post that we've published about this, where we will automatically certify certain data endpoints with a little badge that goes right on our metadata page that shows, hey, people who designed this data have met certain requirements. This data has been tested, it's been documented, and you can know that there's a degree of quality there. So I think with a large data organization, a lot of what you're doing really comes down to communication and documentation, but there's something that you should not do, and that is keep it to yourself. So many of the interesting innovations have come out of large companies who have done really cool work and have decided to share it with the community. So once you figure this out, share it with the rest of us so we can benefit from this. So to sum up, no matter how big or small your data is, make sure that you test your assumptions thoroughly, preferably in a continuous integration or an automated framework. Document your data so people know how to use it, and communicate with your colleagues, both on your internal analytics team and your downstream stakeholders.